Hello, everyone. Thank you for your interest in our work. My name is Alison Diaz, and I'm glad to present you our progress in the bioinformatic analysis and comparison of multiple long-read whole genome assembly approaches of PacBio HiFi human sequence data. So, as we know, the development of next-generation sequencing technologies has accelerated the analysis and characterization of variation in human genomes. But besides its advantages, some complex variation has remained elusive due to limitations of short reads, some of which may be involved in diseases. What happened next is that since 2010, with the development of the three-generation sequencing technologies, we start to see an improvement in sequencing quality and cost reductions, enabling more complete genomes and better identification from single nucleotide variants to large structural variants. Specifically talking about PacBio HiFi, this technology can currently achieve long read lengths between 10 to 30 kilobases with accuracy greater than 99.9%. Also, the recent publication of an alternative human genome assembly by the T2T consortium provides us with the first gaplet assembly of the human genome, allowing the detection of variation in previously unexplored regions like telomeres or centromeres. So, taking all this into account, our goal is to determine if the use of these new discoveries can achieve better results in the assembly and annotation of human genomes, and also facilitate the genomic diagnosis of patients with genetic diseases. So, as a first step, we make a quality control of the reads with long QC and fast QC, where we get a total of 4 million reads. And as we can see in the first plot, the mean read length is consistent with the average length of PacBio HiFi reads between 10 to 30 kilobases, as I said before. And in the second plot, we observe a mean coverage of almost 14x, which is slightly slow since the sequencing was performed at 30x, but we also have reads with more coverage. About the quality reads in the third plot, all reads pass the quality value of 20, which means an accuracy of base call of more than 99%. And finally, we carry out a trimming to look for adapter contamination, and we only filter 2,000 reads, retaining the 99.99% of the total reads. Once ensuring the quality of the reads, we perform 3 different genome assemblies. First, a de novo assembly with HiFi assemb, and then 2 reference-based assemblies with GRCH38 and T2T references. We obtain an assembly length consistent with the approximate length of the human genome, 3 billion each, with T2T-based assembly being slightly larger as expected. In reference-based assemblies, we obtain full chromosomes, 22 autosomes, and the 2 sexual chromosomes, while the de novo assembly is more fragmented due to the lack of a base reference. The mean coverage of the 3 assemblies is almost the same, and we see more sequence identity between our data and the T2T base assembly. So, with the reference-based assembly we obtained before, we carry out a variant calling using Google Deep Variant Program, and we got some extra variants with T2T base assembly. Most of the variants in both cases were filtered out after the second stage of the calling, but we can observe that the majority of the non-filtered variants are single nucleotide variants, especially of the biallelic type. I also want to mention there that most of the variants have a qual score of above 50, which means good base quality call. So in summary, we generated 3 different whole genome assemblies using PacBio HiFi reads through remapping to GRCH38 and T2T human genome assemblies, and also a de novo approach. We observe a better performance of reference-based genome assemblies than the de novo, with minor differences between the use of GRCH38 and T2T as reference. The T2T-based assembly gave us more variants, but in both cases, a large number of SNVs were filtered out, and most of the retained variants are from the biallelic SNVs type. We see that long read sequencing can achieve better genome assemblies than short reads, providing a high-quality template for variant calling and diagnosis of genetic disorders. And finally, our next steps will be the annotation, filtering, and analysis of the obtained SMBs to identify candidate variants associated with the patient clinical manifestations, in addition to compare and understand the differences among these different assembly approaches. So for me, this is all, and I'm happy to take your questions in person at the conference, and hope we have a great day. Thank you.